All right, let me attempt to split screen here. Not very good at split screening on a tablet. I got it to work earlier. Let me try one more time. There we go. Okay. So in section 4.7, it's titled Transformations of Quadratic Graphs. I have some graphs over on the left side, but ultimately what I want to do is just understand the connection between the equation and the vertex. So I'm not going to take the time to graph each one of these, but I have them plugged into Desmos already on the right. But let's take a look at the first one, and specifically the vertex. So I see the vertex of number 1 is -4, -3. I can see that from Desmos. What I'm wondering is if you can notice a connection between the equation of the graph and the vertex. And maybe it helps that we've done this before in a previous chapter, but do you notice maybe a way we could have anticipated that vertex without even graphing it? You see those numbers show up in the equation itself? Take a look in the parentheses. You may notice the sign was wrong. We had to switch to the opposite sign of that number and then look at the number after the parentheses. That seems to have shown up. Let's take a look at the second one and see if it follows the same pattern. Okay, we see when I graph that over on Desmos that we got 1, 2. Take a look at the equation inside the parentheses. Did we follow the same pattern? Yeah, I had to do the opposite sign. In the parentheses, I had x -1, but I needed a positive one. And after the parentheses, I had +2. Well, that's what I had for a y coordinate. Knowing that, can we anticipate the third one before I graph it? Any suggestions on what the vertex might be of number 3? -5 and what do we maybe guess for a y coordinate? -4, -5, -4 is a suggestion. So let's go ahead and graph it over here and see if we are correct. Were we? Yes, -5, -4 is correct. So knowing that, could we predict number 4? What do we suppose maybe the vertex is going to be on number 4? I'll try to make it a little bit trickier. What do you think it might be for an x coordinate? You look inside the parentheses, hopefully you see the -1. So we have to do the opposite, so we go +1. What are we going to have for a y coordinate? It is a 0. That is a good guess. There's nothing there. So we anticipate 0. Let's just verify it on Desmos. It is in fact a 0. What about the fifth one? Probably the trickiest looking one of them. What about an x coordinate here? Can we anticipate the x coordinate? There's not even parentheses. Does anybody have a guess? 1. 1 is a guess. What do we have for y coordinate? -3. Let's check it out and see if it's correct. Oh, it's actually a 0. So when there's no parentheses, that's really like saying x -0 squared. Aren't those really the same thing? If it's x -0, I don't need to write -0. X -0 is x. So if there's just x squared with no parentheses, we can anticipate that as a 0. Now, this is not the first time we've seen something along these lines. Oops. I'm going to try to get rid of split screen. I'm not exactly sure. There we go. Not the first time we've seen this. It looks like this. We call it vertex form, by the way. We've already dealt with standard form, but vertex form looks like this. Y equals a parenthesis x minus h close parentheses squared plus k. And our vertex, then if it's written in that form, look inside the parentheses, it says negative h, so I would switch it to positive h, and then my y value would be the k. So the vertex is hk. That should look similar to something else we've done. Does anybody remember when we've seen these letters before in a previous unit? Nobody. It was the absolute value. So you don't have to write this down, but remember what absolute value looked like, which we've tested on before. Looked very similar. Instead of parentheses and squared, we had the vertical bars, but it had the A, it had the H, it had the K, and the vertex then was HK as well. So we've seen it before, and I think I mentioned at the time, we'll see this nearly every chapter of Algebra 2. So this is going to come back over and over again with the A, the H, and the K. So we call it the vertex form here. And we call it the vertex form because it's easy to find your vertex. We'll do some graphing of vertex form, but we also need to be able to write an equation in vertex form. So let's do a couple problems of that. So let's consider f of x equals x squared plus 6x minus 2. Watch me go through this problem first, and then we'll discuss it. And hopefully some of these steps look somewhat familiar. It's a little bit different than something we've done, but very similar. Oops. I don't know what's up with this weird squiggle there. F of x equals, I'm going to keep the x squared plus 6x together. I'm going to kind of move that negative 2 off to the side and leave a spot for the number I would like there. And I would like a 9 there. Since I added 9 on the right side, I'm also going to subtract 9 on the right side. Now the first 3 terms, the first trinomial factors, x plus 3 squared. And then I'm kind of breaking it apart there. Negative 2 and negative 9 together make negative 11. Oh, doesn't that appear to be in vertex form? And if I asked what the vertex was, it would be negative 3, negative 11. Now that is called, and we've done it before, but it's called completing the square. The difference is when we completed the square before, we were using it to solve an equation. So we had a 0 in place of the y or in place of the f of x. Now, I don't have a 0 over there. I still have the y or the f of x. So I didn't bother moving the negative 2 across the equal. I kept it over here on the right side. I just kind of slid it over, made room for the number I wanted. And then because that was the case, I went ahead and kept the 9 over on the right side as well. But since I'm adding a 9 on the right side, I can't add 9 on the right side twice, but I could subtract 9 and add 9 both on the right side because they would cancel each other out. I didn't want to cancel them out. I wanted the 9 there so I could factor it. But that gave me my answer. If I asked you to graph it, because there's some graphing in this unit as well, now you could just make your table. You know your vertex, and then I would surround your vertex. Maybe you would want to consider like a negative 2 and a negative 4. Plug in negative 2. We switch colors here. We can plug in a negative 2 in place of our x. So in the parentheses, negative 2 plus 3 would be 1. 1 squared is 1. Minus 11 gives us negative 10. And then they should both be the same. There's a real quick, rough sketch of the parabola. Let's do one more. Consider f of x equals 2x squared plus gx minus 1. I want to put it in vertex form, so I'm going to complete the square, but this time I gave an a value. But like the last one, I'm going to kind of ignore the negative 1. I'll leave the negative 1 off to the side. Think about the first two terms. Since there's an a value, I want to factor it out. I'm not going to factor out the x, even though both terms have an x, because I want to complete the square. I want the x squared and the x to stay, but I want to get rid of the 2. So when I pull 2 out of those first two terms, I still have an x squared, and then it'd be a 4x. I'm going to leave a gap because I want to complete the square. And then I still have this negative 1 hanging out at the end. What number will we add into the blank? Remember, completing the square, it's on the 1 to 4, 6 quiz. We've been doing it. You would take the b value, you'd cut it in half, and you'll square it. So our b value is 4. Half of 4 is 2, and 2 squared is 4. So I need to put a 4 there. Because I'm adding a 4 on the right side, what else will I need to do? Subtract 8. I anticipate that catches you off guard. Why would I put an 8 there instead of a 4? The reason is, look in front of the parentheses, there's actually a 2 there. We have a multiplier of 2. Whatever I put into the parentheses, the 4, actually got doubled. So in total, I actually added 8. So I have to subtract 8 also. So if there's a number I factored out, be careful of that. Now I should be able to factor x squared plus 4x plus 4 becomes x plus 2 squared. And then minus 1 and negative 8 become negative 9. There's your vertex form. Your vertex would have been negative 2, negative 9. If I asked you to graph, which I'm not going to take time to do right now, but you put that in the middle, maybe surround negative 2, so maybe negative 1, negative 3, plug in negative 1. To do it, point out you need to be careful. Negative 1 plus 2 in the parentheses becomes 1. Here's where you need to be careful. Squaring happens before multiplication in your order of operations. 1 squared is 1. 2 times 1 minus 9. So that's 2 minus 9 is negative 7. And then you could graph. That should be enough to be able to get you through 4.7. And we can talk about it more in depth later if we need to.